Hello, this is Miss Zwang, and today we're going to determine how many solutions. In the past few weeks, we've been solving equations, starting with one-step equations for addition and subtraction, multiplication and division, and moved on to two-step. Now we're into multi-step, combining like terms, and even recently starting those that involve the distributive property. But here we need to solve each multi-step equation and identify the number of solutions. If there is no solution, we call that zero solution or no solution. There could be one solution, those are the ones we've worked with thus far, where x equals an exact number. That number can be a whole number, an integer, a decimal. It could also be a fraction. Most of the ones we've been working with are integers. There's also an infinite number of solutions where you end up with the left side of the equation equal to the right side of the equation, where some number may equal some number. That number could be 0 equal to 0. That number could be 5 equals 5. Of course, if it's no solution, that's when you end up with two numbers that are not equal to each other, or two quantities that are not equal to each other. Remember, the first step is always the given. I'm going to insert a little 1 in between the minus sign and the x to represent that as a 1x. I'm underlining 4x and minus 1x because they are what kind of terms? You guessed it, like terms. 10 and 4 are also like terms because they lie on the same side of the equation and they have no variable. They are numbers that can be combined. 10 and 4 makes 14, while 4x take away 1x equals 3x. You can abbreviate combined like terms with the acronym CLT, not a BLT. No bacon and lettuce tomato today. Maybe some bologna later. The two items that drop down are the plus 5 and the plus 3x. It doesn't matter whether the plus 5 and the plus 3x are in front or behind the terms, but for our instances, I'm just dropping them down after the terms I've already combined. So, what is my next step? Since there's addition on both sides of my equation, there must be some form of subtraction. I can either subtract the numbers, or I could subtract the variables at this time. I'm going to go with the numbers. I'm going to subtract the number 5 from both sides, just so that I can keep the x on the left side, but move the numbers to the right side. When I subtract 5 from 14, my result will be a positive 9. Don't forget that positive 5 or plus 5 take away 5 or minus 5 will cancel each other out, making it 0. You do not have to record the 0. Simply drop down the 9 after 14 minus 5. Next, I'm going to subtract. The only thing I have left is the 3x, so that it no longer is with my number 9. If I subtract 3x from the right side, I have to also do so on the left side. But when I subtract 3x from a positive 3x, it cancels out, but on both sides. So if there's nothing on the left side, I'm going to use 0 to represent that nothing. I'm looking at this final answer of 0 equals 9, and I know 0 does not equal 9, at least not on this planet. Since 0 equals 9 is a false statement, I can conclude, using these three little dots as an abbreviation for therefore, I can conclude, therefore, there is no solution to this equation.